So we've seen some top line results. We're now moving down our menu on the left hand side, and we're going to explore the data a bit more because we have a very rich data set with all that weather data, all that generation data at fairly high resolution. The question is, where are the interesting places? Where are we going to have problems? Where are the maximums and minimums? Where are we going to get maximum fluctuations? So we've created a couple of tools to help you explore the data and find those places. And the first is called our heat map. And we have two versions of the heat map. The first one shows you generation, and actually I'll make this a bit bigger. Here we go, so you can see it better. Here we go, that's a bit bigger. So the heat map consists of a number of rows, and you'll see one row for every year in our simulated weather data. So from 2009 through to 2018 in this case. Along the bottom you've got January running through to December, so through a year, and then each strip within a row represents an individual day, and it's coloured according to how much generation there was in that day. So the darker colours in all of our charts, darker colours refers to larger numbers. So dark means big generation and light means less generation. Blue normally means combined wind and solar, red means solar, and green means wind. So here we are looking at combined wind and solar, and we can filter these days that we're seeing. If we're interested in looking at the very high production days, we can filter and just look at the high production days. So we can see there are times of year when you get streaks of high production days altogether. We could go and investigate those a bit, but equally and possibly more importantly, there are low production days. So I can filter like this, and this is just showing me the low production days. And if I go and look at this grey area here, these are a series of low production days together. So let's go and click on those and let's see what's happening. If I click on them, this takes us into what we call our Explorer. So basically it's a way of looking at the data by time series and graphs. So this has taken me to that day, the 26th of February, in the middle of that period. In fact, what I'll do is I'll open it up to look at the week. So there's that week, and then we can see certainly some low production days there. What I'll do is one thing I'll point out is you can see that we have a time series here of total production in blue, and we have estimated uncertainty. So these shaded areas show you that our modelling says, our best guess is it's the dark blue line, but the shaded area is saying, well, it could be anywhere between that top or that bottom part of the shaded area. So that's our uncertainty. I'm going to switch it off now just for clarity. So that's our total generation and this poor production week. We can split out the utility solar and the wind, and we can see what's happening. So I can see from this that probably actually, can I show? Let me just change this to power and let me put the capacity on. So these dotted lines are showing you the capacity of a set of wind farms in this case, and the dotted line is the total capacity of the solar, and the unbroken lines are showing you the actual production. So I can tell looking at this that we're not getting much wind generation on these days at all. We're having cloudy days on the solar, good production day on the solar, but then we're back to cloudy again. So it's definitely very low down on the wind generation, with intermittently bad solar PV as well. And we can be pretty sure that this is pretty bad. So you would want your engineers to design your system around these sort of characteristics. The Explorer doesn't just work at the day-by-day level. I can jump up to look at years, for example. If I just In this scenario, this is showing you the inter-annual variation from one year to the next between the generation from this mixed solar wind combination. And I can stack that in instead if we want to see that. So we can see certainly a bit of variability in the wind. That's shown by the green part of the shaded area. So this is a stacked bar chart, and the solar is on top. In fact, if I change the stack order, we can see there's actually a fair amount of variability in the solar as well, which is interesting. So this is one of our model data sets from Mauritius. Just to show you we can utilize other data sets and data sources as well. This is an example, a simulated wind and solar combination in the UK. In this case, we're using ECMWF's ERA 5 land data product, which is one of the global data products. It's a global reanalysis data product. But we're using it because it's got a long time frame that we can look at, even though it's lower resolution spatially. 30 years or 1 hour reanalysis data, as it's called, is quite useful. And Maria will have more to say about that in our lecture. But we're looking at the patterns. We're looking for patterns. We're just looking at the wind component here because we're in green. We could look at the solar patterns as well if we wanted. So this is in the UK. I think we're somewhere in East Anglia, on the eastern side of Britain. So you can see there's obviously a summer-winter variation, but a certain amount of variability, certainly from week to week. UK weather is characterised by quite a lot of variability, especially compared with our tropical locations, which are much more predictable in a way. But if I go and look at the wind, for example, go back to the wind, we might say, okay, we could zero into a bad period here. So I can see a light period in 2002 where there was day after day after day of very low wind. So this is going to become more and more important as we increase the amount of wind generation. As we start putting more capacity in, making the right calls and decisions against this variability becomes more and more important because of the possibilities of upsetting your system and blackouts and strange things happening in the market. So that's a UK example. Oh yes, and I wanted to just show the UK variability. This is total annual generation. Let's just look at wind again. So this, rather than day by day, is looking at the sum total for each year in our 30-year period. And this really brings home the fact that there is very significant variability in our wind, at least in East Anglia. 2010 was a particularly bad year. So these are the sort of extremes that our financiers are going to be interested in. What does bad look like? What does good look like? How often does it occur? So that's our Explorer. And all of these time series can be downloaded. And I've got one last thing to show you. So this is another scenario from an island scenario looking at our Explorer. And in this case, we've gone for a scenario where we have a lot of generation, combined solar and wind, relative to our demand. Let me just try and make this a bit bigger for you. Here we go. Oops, maybe slightly too big. Here we go. Let's move me out of the way. There we go. So this is an island, or an island scenario where we have installed a lot of solar and wind. And in this case, the demand line is shown by the dotted line that's going along the top here. So these are kilowatts, 10-minute kilowatt values, and it may not be very clear to you, but there is a dotted line across the top there, and that is the demand. So that is the net effect of everybody switching on their cookers in the morning, for example, around about here, and then they all go off to work. There's probably a bit of a drop in the middle of the day, and then when they all come home, everyone switches things on, and the demand goes up again. So that's our demand. The lilac area, as I've coloured it in this, is the generation that we're getting from renewables. The red area is what is left to be covered by diesel generators, in this case. So the red is the stuff that's got to be provided by diesel generators. And you'll notice in the middle of the day, we've got so much solar that we're now exceeding the demand curve. And this green area is showing you by how much our renewable generation exceeds the demand. So something has to be done about this. Demand must always equal supply at all times. And there are 3 strategies for dealing with that. One is you store it. So you store it now and discharge it later. Or you try to suppress or increase demand even at that time. So this is called demand side response. Hey everybody, there's lots of energy available, switch things on. Businesses switch on. Factories switch on to help balance. So that's demand side response. Or thirdly, you can curtail, which means you just switch it off, the renewables, and you throw it away. And all of those 3 are valid strategies in different cases. We can tell you this is happening. At the moment, we don't model what to do about it, but that's something we're working on at the moment. So there we go. That's a very quick tour of our Explorer and our heat maps, and it shows you the sort of things we're starting to look at if we're analysing scenarios and trying to decide where are the important features, and then we can highlight to consultants that something needs to be done about them. So there we go. That's exploration of the data. Thanks.